Most of my career has been spent in the Great Plains, and so I've worked mostly with Great Plains natural grasslands or native grasslands. And most of that would have been tallgrass prairie, some mixed prairie, and that would be from the northern Great Plains to the southern Great Plains. In the northern mixed prairie, that was in South Dakota, in an area west of the Missouri River. Locally it's called West River, South Dakota. And it's quite a bit different than the southern mixed prairie. When I interviewed there, in fact, I just thought it was remarkable that there was a mixed prairie without any shrub component. So here you had this overstory of cool season grasses and an understory of warm season short grasses, and those are blue grama and buffalo grass. So that was just really fascinating to me, how in fact you could create a shortgrass prairie with grazing pressure by any of the grass eaters, but especially cattle would prefer those taller cool season grasses, and they were pretty easily suppressed with grazing, and you could create this shortgrass prairie out of a mixed prairie of mid grasses that dominate the overstory. So I have worked in woodlands, natural woodlands, and in forests, and that was really fascinating. It's an interesting system because if fire plays the proper role there, it's more like a savanna. It has scattered large, stately, shortleaf pine trees with an understory that looks like tallgrass prairie. And so I worked with Ron probably about 10 years there. And then I had also worked for a couple of decades in the cross timbers, which is a post oak, blackjack oak forest or woodland, and did work with fire and effects of fire and herbicides on that ecosystem. My favorite ecosystem would have to be in the plains, because I was born and raised in the plains, spent most of my growing up years and then my adult years in the plains. So although I like being in the forests and woodlands, I get claustrophobic. The beginning of my career could be considered when I was a student, really. And even as an undergraduate in Texas, I went to Abilene Christian University, and my professor there, range management professor, was a contract with Dr. Henry Wright, who's kind of I think you could say, he's considered the father of modern rangeland fire ecology. So I got to work with Dr. Wright, and I got to burn with him and collect data in the Edwards Plateau, central Texas, where a big issue was juniper encroachment. And he developed over time some really innovative fire prescriptions to be able to burn in that highly volatile juniper fuel. Well, the state of science was pretty young, but the state of the acceptance of fire was highly flammable, pardon the pun. And I'll never forget a field tour we had, brought probably 150 people, which is a large field tour, to a ranch. This is the old Beckham Ranch outside of Abilene. And I really thought, I was a little bit concerned for Henry's welfare, because there were a lot of people extremely upset with him. And these would have been the kind of the gatekeepers on technology and on range management practices in the state of Texas. Now, my professor he favored fire, and we used as a textbook in rangeland ecology. It was called Range Ecology by Humphreys out of Arizona, and he taught us, and that book taught us, that fire was natural. In fact, it was a natural part of climate. And so I was a little befuddled by the fact that everybody was so anti-fire with Henry Wright. When I came to Oklahoma State in 1983, I was interested in fire, but it didn't take me very long to realize that landowners, ranchers, had a very negative outlook on fire for the most part. But I learned from that first of all, there wasn't a lot known in Oklahoma. Really, the bulk of the fire research was in the Flint Hills of Kansas, tallgrass prairie. So we didn't know a lot about fire in the 80s from a science perspective. Landowners' attitudes, let's say in the 1980s, even maybe into the 1990s and before, was negative. But there was one study in particular in Oklahoma that reflected very negatively on watershed effects of fire. And there's even a fact sheet on that, which is an extension publication, especially for ranchers or landowners, that said basically you don't want to burn. Fire is a natural process and a good thing. That's what I read from Humphreys, that rangelands, in fact, evolved, the plants evolved, and then the animals evolved with fire, fairly frequent fire. If that's the case, how can we employ fire to benefit? I believe that's probably the case. Let's just see how much. How much production do you lose, and what's the influence of burning date on production? So I think the concept there is clearly that fire has a role, and it's interesting and fun to determine what that role is and the magnitude of the influence. I think one of the most surprising things to me was that when we burned through the dormant season, this would be in central Oklahoma, north central Oklahoma, from middle of February to the middle of April, there was either no influence to that earlier burn date, it didn't decrease production, or a slight improvement. One of the most profound influences on my career in fire ecology was when Sam Pullendorf came to Oklahoma State. And I'd done this research on fire ecology, plant and soil responses to fire, and some wildlife research. And one of the things that really troubled me was, at the time, a common prescription to benefit ground nesting birds, especially game birds like northern bobwhite, was to disturb the soil surface through basically cultivation. So you might, for example, pull a disc around the perimeter of a pasture. And that bothered me. Who was it, or how was it, that bobwhites and other ground nesting birds like prairie chickens did so well in Great Plains grasslands without tillage before Anglo-Americans arrived? And so Terry Bidwell and I came up, we were on a field day in western Oklahoma in the heart of bobwhite quail country. And he and I said, well, let's create some food plots, because we'd done some small plot burning, and if you don't fence small plots out from cattle grazing when you burn them, they will only graze those small plots. And then what do you have? You have a weed patch, which really is a food plot, habitat plot for bobwhite quail. So let's do that. Let's do that. Well, at the same year, Sam Pullendorf came, and we told him about that idea, and he said, "Oh man, that's an ecological truism. It's an ecological principle that landscapes need heterogeneity." And so from that came the idea of really patch burning, the practice of patch burning eventually. To me, that's a profound difference than what I was schooled in, what I taught, what I encouraged ranchers and agency people to do for a long time, decades, which was homogeneity management. So, in fact, entire series of lectures in principles of range management are built around obtaining uniformity of the vegetation. That's homogeneity. So that's a huge change in the Great Plains, and one that I'm very proud of, but also changed the trajectory of my career and to its benefit. I think this is in 1979 or 1980. I brought students, range management students, from Brookings, South Dakota to Tulsa, Oklahoma, and promised them that we would see, because I'd heard that there were red cedar trees in Kansas and Oklahoma. I said, well, we'll get to see an actual standing red cedar tree. And never saw a red cedar that entire distance. To a research scientist and a university is funding for their research. When I first came to Oklahoma State, a researcher could do some decent research on the internal funding. You know, they didn't have a program area for fire ecology per se. You would have to use it in whatever call they were issuing. But the Joint Fire Science Program has really made a big difference and helped us, especially those of us that do more of the applied research, that is trying to solve immediate problems, pressing problems. That's one that's turned out well, and I certainly hope for the benefit of the science and the practice of prescribed burning that we continue to see that funding mechanism. I'm most proud of the people that have benefited from working with me, and of course that's mostly students and graduate students. I have had students who worked with me because I did fire research, and there's not very many people that do that. But I'm proud of that, and I keep in touch with most of them. Students, for example, who are in North Dakota, graduates there, or Wyoming, they're into fire. Even though the culture there, even in the university, has never really had much in terms of, or any fire, they're trying to pursue that. And that's, to me, I'm really proud of that. And so they see those opportunities. They're ambitious and entrepreneurial and really good people. So to the extent that I help shape them and help shape their careers, I'm extremely proud of that. How dedicated they were to their work and to the resource, to the rangeland resource, and like Henry Wright, to fire and rangelands, and to professionalism, basing their work on a science, who were also abundant givers to students and to ranchers and to agency people. And I can give you a long list of those people. And so I hope my legacy is that I fit in with that group. And people will look back and say, yeah, Dave Engle was one of those. He was one of those that did that. And I really have benefited from a host of people that maybe even most people in the Great Plains wouldn't recognize. People like Francis Churchill at Abilene Christian University, Tex Lewis at South Dakota State University, they schooled me. Henry Wright schooled me. He's more famous in the fire area. So one of the great needs we have in agriculture and natural resources, but especially natural resources, more so than production agriculture. But that is the wide gap between research, knowledge, acquisition, and application. And maybe even between research, knowledge acquisition, and the distribution of that knowledge. Not necessarily its application, just its distribution. I was shocked, for example, when I was talking to a researcher, real high level, this is a water scientist in my role as a water center director. Funding galore from NSF, National Science Foundation, heralded as the next brightest young water scientist. And I said, well, how do you extend your How do you extend your research to the user? How does that happen in your case? He said, well, it doesn't happen. That's pretty serious. So he has no trouble at all bringing in multi-millions of dollars for research funds, but there are $0 available to take that to the user. And when I realized it there, I argued, unsuccessfully I might add, for the most part, with the people above me that you need to pay attention to this, because in Washington, D.C., they're interested in this. Okay, if you say those two things work together, the agricultural experiment stations and the cooperative extension service, show us. Well, I can show you a lot of places where it doesn't. Now, that doesn't mean it's always that way, because I can also show you some extremely successful ones at Oklahoma State University, extremely successful. And I'd worked in natural resources where, in a department where we had the extension specialists within the department, and we did research together, and we also did extension programming together. But I think that's the exception, not the rule. And I was very fortunate, and I think that has advanced the application of that science many times over.